Alrighty, yeah, so again, welcome to our Math Methods 3 and 4 revision lecture for the September lecture series with ATAR notes. And yeah, my name is Boyana, and I'll be taking you guys through the next 2.5 hours. So a little bit about ATAR notes. So we're nearing the end of our lecture series, but we're essentially a company that designs high school resources for use by students, and kind of the special thing we have is that it's mostly made by recent past students. So people like myself who have graduated from the ATAR system recently have got that experience and that first-hand kind of knowledge of what it's like to go through it, and then hopefully we can impass knowledge onto you guys about how to do your best. So some other things we have going on, kind of like on our website especially, this is kind of where you can find everything. So we have like revision videos online, and all of this is super useful for your external prep, so I definitely recommend just kind of having a look through the website. But we have like an ATAR calculator on there, we have newsletters to keep you in the loop with everything, and a big thing actually I want to point out is we have these articles, really useful, with like study strategies and tips. A lot of my like colleagues here have written a lot of articles kind of like outlining their personal experience with different parts of the ATAR system, how they approached certain assessment. So there's a lot of really useful stuff there. And also a lot of downloadable notes, sample assessments, everything like that as well that people have uploaded. So definitely check out those contributions. And again, everything's on the website, so feel free to go in. I think you'll be able to log in with the same account you used to check out the lectures, and everything is on there. So if anyone's got any questions about that as well, I can show you guys a bit later. And then also some other things we provide, we have our tutoring program, TuteSmart. I'll speak about towards the middle of today, especially how you guys can kind of capitalize on it preparing for your final exams. It's not too late to get tutoring. And also we have our study guides and Ed Unlimited. But that's for later. So a couple of housekeeping things. Today we have about 2.5 hours, so we'll have pretty much like a halfway break, about 15 or 20 minutes. We might put in some other breaks here or there depending on how we're going, but we'll just see how we go. We'll basically have 2 main blocks of content and some questions sprinkled throughout for you guys to have a go at. So yeah, hopefully today will be some good revision for you. And again with Slido, if you see some questions in there that are similar to yours, just upvote it. But also please feel free to spam Slido with questions. It will just sit in there until I get to them. And also if you're looking for some extra resources for study, I'll show you some places throughout the lecture. So feel free to just chuck that as a question as well. Alrighty, so a little bit about me. So I graduated from Brisbane State High in 2020. Probably a few of you guys are quite familiar with me by now. I've been doing lectures for ATAR notes for quite a while. So since I actually graduated from year 12, so all of last year and all of this year, I'm in my 2nd year of uni now. I'm doing medicine at UQ. So that means I sat the UCAT in year 12, and also obviously I got an ATAR when I graduated. So my ATAR was a 99.05. And yeah, I'm really enjoying UQ. If anyone has any questions about like uni degrees, I know that today's the day that like QTAC applications and all that close. So if you have any questions regarding that as well, feel free to ask. But yeah, really enjoying my time at UQ. I love to play netball. I did a lot of it in year 12 and I'm still doing heaps of it. And I also really love to teach. So I really enjoy giving these lectures. Kind of like, it's nice to have like studies, enjoying medicine. And then also my work, I really enjoy teaching. So kind of, I don't know, following the different things I enjoy and I'm passionate about. This was me on graduation day and the little photo there. And also if you've got any personal questions, just chuck them in Slido. I'm more than happy to share. Obviously I've been through year 12 and all that and made it out the other side. So more than happy to give advice or my thoughts on anything. So what we're going to be doing today, and I'd like to say we're going to basically cover everything, but we're going to kind of go the main ideas in quite a few topics, especially focusing on Unit 4. So hopefully everything at this point will be revision for you guys. You would have gone through everything in class. So if there's something that you guys are kind of like feeling all right with, feel free to chuck it into the into Slido as well, that you guys kind of want to focus on some other topics. But hopefully I'll give you guys some revision on the ones I have selected. Alrighty, but before we get into that, see if we have any. Nice, okay. So we've got optimization, statistics. Cool, because what I was thinking we can do today with statistics is actually sit down and go through like on a document, like go on the screen together, make a summary of all the different types of statistics. Because what I found consistently among students is that people kind of struggle with the statistics questions, figuring out exactly what kind of statistics they're dealing with. And then that means like what kind of formulas will you have to use. So we can definitely go through that. Continuous random variables will be part of that. Optimization, 100%. I think we've actually got that. So I think my main problem with methods is that I understand the content pretty well, but I struggle to understand what exam questions are asking me, particularly the more complex ones. Any tips? Yeah, absolutely. So throughout the lecture, I'll kind of mention how you can translate the content into exam questions and kind of how to, look at an exam question and, first thing you do when you open your exams, kind of identify with a question, all right, what topic is this asking me? What knowledge does that involve? And then kind of going from there. So we'll definitely be able to discuss that today. If anyone's got anything else, feel free to chuck it in. I'll run a couple more polls just to gauge how you guys are going. But again, I want today to be as interactive as possible, even though, it is an online stream. And then we have deriving and integrating natural logs. Cool. Okay, we can also have a little discussion about that. So hopefully I'll actually be able to address everyone's kind of specific topics by the end. Alrighty, cool. And no questions thus far. And stream's all good. Alrighty. So first thing I want to do is a little refresher on Unit 4. So we're going to look at the second derivative, trigonometry, and some basics with probability. So the second derivative is a concept, hopefully, that you guys are feeling alright with and how you can kind of apply it. But if not, that's what I'm going to talk about now. So yeah, starting off year 11 with kind of being comfortable with deriving and integrating. So absolutely for your external exam, if you feel like you don't have good foundations with deriving and integrating kind of just like at that simple familiar level, 100% just grab a textbook and just drill yourself on as many simple familiar as you can, just to make sure that you're deriving and integrating at a level where it's essentially becoming second nature. So that's kind of really important, because then when you get to your more complex unfamiliar questions where you kind of just have to be able to derive and integrate just like that, because the tricky part of the question is the context or figuring out how you're going to get to the answer more so than actually doing the math itself. So 100% top tip, if you're feeling not too confident at this point, like a month out from the exam, with that kind of being able to just derive and integrate confidently, just go through a bunch of simple familiar, sit down, practice, mark your answers, and I think that will set you up really well. Alright, so again, a couple rules for differentiation. So we've got our power rule, our kind of most basic differentiation rule, then we have our product rule, quotient rule, and also the chain rule. So a few different ways of representing it here, and hopefully you're familiar with your data, the formula book actually that you'll be provided. So if anyone doesn't know what that looks like, that will be here. So your methods formula sheet. Another tip is if you haven't already got a copy of this printed out and next to you every time you do methods, definitely a good time to start doing that. You'll get used to kind of what you are provided with in the exam, and then when you get to the exam and you have your formula book, you'll know where everything is as well. So we got these rules for differentiation there. So essentially, to get the second derivative, all we just have to do is just derive again. Hopefully you guys are alright with that concept. So if we have a function fx, if the first derivative is f dash x, then the second derivative is f, and then essentially double dash x, and then it goes, you just kind of keep adding a dash for each derivative you do. That's kind of the notation there with the second derivative. So what the second derivative can actually do is that it can tell us more about the shape of a graph than just the first derivative alone. So if you remember, we can use the first derivative to kind of figure out some properties such as stationary points, what's the slope of the curve at different points of the graph, and the second derivative can actually just kind of further that knowledge. So if the first derivative gives us the rate of change of a function, what does the second derivative actually give us? So it's the rate of change of the rate of change, and it will tell us whether the slope of the function is going to become more positive or negative. So it's actually kind of anticipating what the future change in the curve is going to be, which is a pretty cool concept. So the slope is about to decrease at this stationary point up here. So what that means is that the second derivative is going to be negative. So first derivative at a stationary point is going to be 0, because as you can kind of imagine, tangent there would be horizontal. However, the way that it's kind of anticipating, the way that the curve is kind of heading from there as you go left to right, is that it's going to start decreasing. So at that point, at that maximum, the second derivative will be negative. And then here, the gradient is about to increase. So even though, again, first derivative will be 0, the second derivative is going to be positive because it's going to be increasing up that way. So something else actually worth mentioning is that all of these slides you'll be able to access yourself. So underneath the video to the right, there should be a little area where you can download the slides from today. And also the lecture's being recorded. So if you come back onto this exact web page you're on, you'll be able to watch the recording. But also if you go to the 8 Notes website after today, it will be put in there underneath lecture recordings. All right. So essentially the summary here with our second derivative. So this is kind of like a good summary, probably what you guys need to really take away. So if your second derivative is greater than 0, then the gradient is increasing and the curve is concave up. If it's less than 0, it means the gradient is decreasing and the curve is concave down at that point. And if your second derivative is equal to 0, it means that you're likely at a point of inflection and the shape is about to change. So that's what we call a point of inflection there, where we have this kind of concave up and then it's about to change into concave down. So that happens when the second derivative is equal to 0. Alrighty, just checking in with Slido. If you've got any questions, I'll just keep flicking back and forth between the two. So cool, we have comparing fx to f-x or f"x graphs, please. Yeah, so is it I think these are the ones where we have, you have to kind of draw the first or second derivative based on the graph above. Yeah, I think I know the type of question mentioned there. So probably my key tips there is that if you're drawing, so let's just assume that this red graph is fx. And let's say we have to get the graph of f-x from there. Would absolutely start with your, with your stationary points. That's the first thing I'll do. So we'll have a practice of doing. So if we're going to draw the graph of f-x over the top of this, and I'm just going to clear what I've drawn. So the red one is fx and the green one is f-x. So the steps to take here is that you would start off with your stationary points. So stationary points are always going to have a gradient of 0. So go like that. And then from there, we just look at the trend of the graph and we either put it as above or below the x-axis. So if the slope is increasing, that means the first derivative is going to be in the positive section for any point that it's increasing. So here we can see that the graph increases all the way up to that first stationary point. So that means we can just draw that this will be positive. And then you can see that we have a negative gradient from the first stationary point to the second stationary point. And then after that it becomes positive. So that means that this graph is going to have to come down, and apologies for my awful drawing, and then it'll come back up. And then from this stationary point onwards, it's positive. So that's why it's going to be above the x-axis. So kind of think of it as any part of the slope that's positive has to sit above, and anything negative has to sit below. And we start off with the stationary points being our points that are 0, because the gradient is 0 at those points. So that's the first thing to kind of think about with your first derivative graph. Then the other thing you can do to check is that if you're deriving and you're going from, so this original graph is a cubic, then you should know that the first derivative is going to be 1 degree lower than that. So if you start with like a cubic, which is x to the power of 3, if you derive that, eventually you're going to get x to the power of 2. You'll get a quadratic. So that means the second derivative should be a parabola of some kind. Oh, sorry, the first derivative should be a parabola of some kind. So even though this looks like awful, like really awful, you can kind of tell this is meant to be that parabola shape. Like that. And then if we're going to extend it onto into the second derivative, I'm actually going to run a poll and ask you guys what shape do you think it'll be. I see someone's typing there, so I'll let you continue. and then a graph of first derivative from the second derivative graph. Cool, we can go over that as well. But I'm just going to ask you guys, so I'll open that poll up in a second again, but what shape should the second derivative be? So what kind of shape of a graph can you expect if our function was a cubic? Then we derive it to the first derivative and we get a parabola. And if we derive it again to the second derivative, what shape should it be? I'll keep that open for a bit. Linear, perfect. Okay, seems like you guys are good with that. So then from there, to go from the first derivative to second derivative, we just repeat the exact same steps. So we just pretend that this is just the original function now, the green one, and we're going to do f double dash x. Alrighty. So now we look at the green graph. Where's our stationary point? It's here. So that means that that point is going to become 0. That will go to 0 because our y-axis represents the double derivative. So next bit is, so to the left of the stationary point, the graph is decreasing, so that's going to be the negative portion of the linear. So it's all in the negative, remember, negative will be underneath. Then it's an increasing slope after that stationary point, so then it's going to be going like that. Cool. So now you can see to go kind of down from the function to first derivative to second derivative, you kind of just step down like that. And then thinking about going in the reverse. So main thing, so if you take so let's take the yellow line, and if we want to try and relate it into the green graph. So main thing is that we know we have a stationary point here from our any point that's 0, we know that we have one stationary point. So that's how we can go, okay, at that point there, we're going to have some kind of maximum or minimum. And then we can look at what's on the left and right of the yellow line. Actually, I'll do this in a different color. So again, you just kind of have to piece together the information the same way that you did doing your derivative graphs, and then in the other way. So if you have your point there, then we look, is it going to be a maximum or a minimum? And we can use the rest of that yellow line to figure that out. So on the left, so to the left of that point, we can see that it's negative. So that means the slope has to be decreasing down to that point. And then it's going positive. So that means that the slope must be increasing after that point. So the thing is, unless they give you some more information, you can't quite correctly scale the graph like vertically. So as you can see, this purple graph is above the green graph. But provided that you like give the correct shape, that's the main thing. So awesome. Okay, good. Thanks, guys. Very glad that that is okay. So someone asked as well, is the sorry, my question isn't loading, but someone asked, is the red line the first or second derivative? So the red line is actually your where is it at? That's your just original function. So I'm going to call that fx. And apologies for my super messy annotations, but hopefully you guys can get the main takeaways there. So that red line is fx. Alrighty, so that's a little bit on kind of drawing those graphs. Again, piecing together information. If you're going reverse, so if you're going from like second derivative to first derivative, etc., unless they give you some more information, usually you can't tell how high or low the graph is, but you can obviously tell where it should be left or right, because anytime it goes to 0, that will be a stationary point. So at least hopefully all of your stationary points will be in the right point, and also your slope will be going in the correct direction. So again, I know there's a lot of like messy writing on the screen now, but if you want to what do you call it? If you want to watch this back in the recording, then you'll be able to go through it again. Alright, so again, summary there with your do you call it, with our second derivative. So if we have f double dash x is greater than 0, the gradient is increasing. F double dash x is less than 0, then the gradient is going to be decreasing. And if your second derivative is equal to 0, it's likely at a point of inflection and the shape is about to change. So going from concave up to concave down in the original graph itself. So also make sure you don't get confused that if it's equal to 0, that means that the f dash x will be at a point of inflection. If your second derivative is equal to 0, that means the original graph is at a point of inflection. So you can see here that that point of inflection, so the second derivative here, this is your point of inflection on the red graph, but it's not the point of inflection on the green graph. So make sure you keep those things different as well, kind of separate in your mind. All right, so another common kind of question that seems to pop up quite a bit is applying the second derivative to position, velocity, and acceleration. So hopefully you guys have gone over this before, but if you haven't, so the position of something in a straight line is usually given by this function. So it will be some kind of equation that's equal to x, xt essentially, and then its velocity, so the velocity will be the first derivative of the position function. So v, or we can go vt is equal to x dash t, and then the acceleration is the derivative of velocity. So that's going to be the second derivative of your position function or the first derivative of your velocity function. So hopefully you can kind of relate that's how that kind of links, where acceleration is a rate of change of velocity and velocity is a rate of change of position. So understanding this relationship means if you know one of these functions, you can unpack basically the rest of them and figure out information from the other parts and then use that to, you can apply it to a question. So this is a really important relationship to understand, the link between position, velocity, and acceleration. Alrighty, so I've actually got a practice question up here for revision, and then obviously I'll go through the answer if you're not feeling too confident, but I would like to give you guys some time to have a go at it yourselves. So position x of a particle is given by this equation. So part A, B, and C. So you want to find the function for the acceleration of the particle, find the times at which the particle is not moving, and then find the times at which the particle is not accelerating. So I'll give you guys about 5 minutes to have a go. I'll double check if we have any. Nope. I'm just going to run that original what would you like to work on today. Otherwise I will leave this up. Hopefully you guys can have a go at it. And the time is 9:55 on my what do you call it, on my phone, so we can go for until about 10 o'clock and then we'll go through the answer. What I'll actually do, sorry, I will open up a poll for you guys to submit your answers. So again, completely anonymous, so feel free to chuck your answers in there, and then we can go through them together. There we go. Something else I was going to say as well is that at the end of today, we'll have a discussion about kind of how to approach the exam and kind of my main tips on how to tackle the methods externals. we can even have a look maybe at some of the sample papers. I'll kind of show you what I would typically look out for in a question. And yeah, we can kind of go over your questions with like time management and things like that for the exam. So yeah, also so stick around for that at the end as well. That will be very useful. Alrighty, cool. I think it is about 10 o'clock. Got a few answers. Very cool. Hopefully answer that question. So the red line was just the original function before. 0, 4, 8, 2, and 6. Cool. Got the same for the top one, I believe. Yeah. Alright, awesome. So keep submitting in your answers and I'll start explaining each bit. So the first part is to find the function for the acceleration of the particle. So like we were saying before, finding the function for acceleration is going to involve finding the second derivative. So we have the position function, and then we're going to turn that into the velocity function by deriving once, turn it into the acceleration function by deriving again. So we start with 4 minus 4 cos pi t over 4. So to do our first derivative, essentially this part will just disappear. Farewell. And then here we will go, so we have negative cosine. If we derive that, that's going to become positive sine. So then, again, multiply by what was in the derivative of what was in the brackets. So we have pi over 4 times 4 sine what was in the brackets originally. And then we're going to cancel out the 4's there. We just end up with pi sine pi t over 4. And then we're going to find our second derivative now. So we go from sine, if we derive sine, we're going to end up with cosine. So we have cosine, what was in the brackets, and then pi, and then what we're going to multiply it by is the pi on 4 again. So if we bring that out the front, so pi on 4 times pi will give us pi squared on 4, cosine pi t over 4. Nice, which seems to be what majority of people have gotten, which is great. All right, awesome. One, there we go. Alrighty, so the next part is to find the times at which the particle is not moving. So we have to relate it to our velocity, so it won't be moving when our velocity is 0. So we equate that to 0, and essentially, so that'll be 0 equals pi sine pi on 4t, and then I believe actually everyone's gotten 0, 4, and 8 seconds. Nice. So again, recall that sine of 0 is going to be 0, so that's your y value at this point over here, and also any integer of pi, essentially, so like you can have sine pi, sine 2 pi, sine 3 pi, the y value at those points are always going to be 0, and you can see that on this unit circle right here. So that means if we chuck in pi on 4, what do you call it? So if we go, I completely lost my train of thought. So 0, go back to here, substitute in 0 for our velocity, equals pi sine pi on 4t. Get rid of the pi, so we're left with sine pi on 4t equals 0. So anything that essentially makes pi on 4 times t equals 0, pi n, equals 0 as well, that's going to be giving us essentially values where our sine is equal to 0. So that would be 0, 4, and 8 as well. They would all produce a sine value equal to 0. So those are the times in seconds that our velocity is 0 and a particle is not moving. And then next part again for acceleration. So acceleration, we just take what we found in part A of the question, we equate that to 0. So we're going to find again now when cosine pi on 4t is equal to 0. So if we think about our unit circle, cosine is 0 here and here, so at pi on 2 in basically any integer of pi on 2. So we have pi on 4 times 2, that will give us 0, and then pi on 4 times 6 will also give us 0. That should be cosine as well. So ignore that bit. So the times are at 2 and 6. So the way that most of these questions go is that you have your original function, then you have to find the rest of the functions and then apply those functions in different scenarios. So yeah, hopefully that was a good bit on the second derivative, because the next part we're going to look at is actually optimization, and I'm pretty sure someone actually mentioned that. 2 and 6. Alright, looks like everyone was on the right track. So we have a missing answer there with just 2. Alright, that's a good job, guys. Looks like you're on the right track. So going back to that earlier poll, we had I think someone mentioned optimization. So here's kind of a little bit of a summary slide on optimization. So what that means is that you're finding the minimum or maximum value of some kind of value. And in these problems, the value we find is optimized. So using the second derivative can actually make it a little bit easier than maybe, how you did these problems in year 11. So a couple of examples is to find the greatest volume a cylinder with a set surface area can have. Find the optimal number of t-shirts a manufacturer can produce or should produce to maximize profits, or find the time at which the tides will be at their lowest. So those are some examples of questions with optimization. And going back to kind of how can we identify different types of, I guess, like exam types or exam question types, when you're setting a paper. So sometimes it can be a bit confusing kind of figuring out what kind of math do we even need to use here. So if you kind of have one of these questions that's trying to find the greatest or the least or a certain time, you probably will be looking at an optimization question, especially if it involves rate of change or having to use, what do you call it? If you can tell you'll have to kind of do some kind of differentiating. So that's kind of a summary with optimization there. Alright, so the next bit we're going to do is trigonometry, and I'm just going to double check we don't have any more questions. Otherwise I want to end that there. So that one, integration by parts, deriving and integrating natural logs. Optimization. So with optimization, I'd especially recommend having a look at a lot of practice questions, and almost always they will involve, oh, actually we'll be on here. It will involve using a combination of formulas, especially from here. So, using surface area, and the idea with optimization is that you want to end up with a formula where you have one x value and one y value. So you can see that a lot of these, for example, like volume of a cone, you have the radius and also the height in there, as like in the kind of where you only want to have one x value. So you have to find a different formula that will hopefully be able to be substituted in, so then everything is expressed in terms of radius, or everything is expressed in terms of height. So that's something to look out for there. Alright, so a little bit on trigonometry. So a little summary there with your trigonometry. So you'll have all of your trig ratios. Hopefully you've been doing them for quite a few years now. Also, this is a really useful thing to know. Not a lot of people actually know that, where the tan of an angle is equal to the sine of that angle divided by the cosine of that angle. And then we have some congruence tests in there. So the sine rule is just like that, where the A, B, C values correspond to all these bits of the triangle. Generally, I find that people are usually pretty good with this trigonometry topic, especially because you might have already done it before in high school. And then just another reminder that if you add up all your angles inside a triangle, it would add up to 180. Another thing that seems pretty simple, but you would be surprised actually how many people forget it in an exam situation. So just as a little bit of a trig refresher, hopefully this shouldn't take you guys too long. Have a go with this question. I'll open up a poll first. Again, so answers to the trig question. Quick refresher. Oh. Alright, so I'll give you guys a few minutes to have a go at that. So we're finding an angle and then finding the length of two sides. So I'll give you about 5 minutes again. We might go a little bit less than that, but we'll see how we go. And actually, I'll give you guys one of my tips while you're working through that, if you're still working through it. So for methods, probably figured out by now, it's 100% doing as many practice questions as you can to prepare for your externals. So a lot of content you have to cover. You've got all of Unit 3, all of Unit 4. So throughout the next month, obviously you'll be preparing for your other exams as well at the same time. So you might have 5 or 6 subjects kind of going at once. What I'd recommend is spending a little bit of time every day doing some methods questions. And I don't mean like sitting down and doing like an hour session, even in the morning, before you kind of get started on anything else. Get, even just 2 or 3 quick methods questions, have a go at those, just to kind of keep all the information fresh. And you can pick questions across the whole year. Yeah, if you have a practice of that, and then kind of that will add up a lot, and it will kind of add up a lot before your exam. And also it's a pretty kind of low effort way of fitting in quite a bit of revision over time, and it's got that idea of spaced repetition and retrieval as well. So you will be kind of reinforcing information consistently, and enforcing different information consistently if you pick across a few different topics. And also it isn't as tiring and it isn't as intimidating as, for example, sitting down and doing methods for a whole afternoon or evening or something like that. So 100% would recommend that you, kind of consider doing small, little, tiny chunks of methods every now and again to make the make the studying less tiring, a little bit less stressful for you. And trust me, it will really help add things into your long-term memory. So see how we're going with our responses. Cool. Very nice. Seems like everyone's kind of got some answers in. So let's go. I reckon we're good to go through A, B, and C. So to find the angle. So going back to the idea that all of your angles add up to 180 degrees inside of a triangle. So all you have to do is go 180 minus 32 minus 78, and hopefully you'll get 70 degrees. Then we're going to find the length C. So we have some information. We've got the angles now, and we have one side. We've got A. So that means we're probably going to be using the sine rule. So we can set it up like so on the left. So one way of doing it is, alright, so we got 40 over sine 70 equals C over sine 78. So kind of getting rid of that part in there. If we rearrange, we're just going to multiply this by sine 78 and get 41.64 meters. And then to find, just want to double check, so to find B, we're going to do essentially the exact same thing. B, there we go. So we can go 40 sine 70 again, and now we're going to disregard this point of question, and we just rearrange to solve for B, based on what we have left, and we get 22.56 meters. So I think everyone got those. Cool. Seems like everyone, for the most part, got those correct. Double check your calculator setting as well. Check it's in degrees rather than radians. And make sure you're feeling alright with your sine rule as well. So something to look out for the sine rule is to make sure that all of your lowercase, so all of the lengths are on the same side and all of your angles are on the same side. Doesn't matter if you flip it upside down, as long as you kind of keep it consistent across. So that's a little bit of trig revision there. So that's the sine rule, and then the cosine rule is where you have 2 sides and 1 angle. And then we have also kind of like a version of the cosine rule where we have 3 sides. So that's where you just rearrange the original cosine rule to find an angle. So a couple of applications there. If you kind of struggle with remembering trigonometry, the formulas and kind of when to use them, I'd consider making a tiny little table. You can even do it on like a post-it note, just saying what information you're given in each one and what scenarios you'd be able to use each rule. So when you have this information and don't have this information, that kind of thing can be useful. All right, so we have another question here, a little bit more of a tricky one with a quadrilateral, PQRS. So we want to find the length of PR there, the angle PRQ, so with that angle in there. and then the length of PS. So I'll let you guys have a go at that. But also just keeping an eye on the time. 10:17. Yeah, so we'll have a go at this question, and then after that we'll wrap up the last bit of content before we go for our first break. So I'm going to add another open text. So have a go at this question. It might be a little bit different to what you've seen before. Answers for the quadrilateral question. Let's launch that. Cool, so the poll should be up and running. Now you guys can have a go at your quadrilateral there. So we'll probably wrap up around 10. We'll go with 10:25. I'll let you guys have a go at this question. Alrighty, we're nearing 10:25. Also, if anyone wants any more time to have a go at the question, feel free to pop that into the Slido as well. Nice, we got quite a few responses, which is good to see. Maybe give another minute or so, and then we'll go through the answers together. Right, it seems like most people are on the same track. And yeah, it makes sense as well that you guys probably have some differences with rounding. Let's see, 38.63 degrees. Alright, awesome. Got quite a few responses, which is looking good. And it seems like, again, most of you guys, I think everyone's got the same answer for A, which is very good to see. Alright, keep chucking them in, and I'm going to start going through the answers. So the first one is to find the length of PR. And it probably was a bit cheeky of me to draw that line, but hopefully that's what you would have done as well, just to visualize what is that length. So for that one, we can use our cosine rule. So we have c squared equals a squared plus b squared, etc., where PR is our c. So it's opposite an angle that we know. That's the key thing of the cosine rule there. So it seems like you guys didn't have any issues with substituting in. Therefore, we have the 12 as the a value and the 16 as a b value. Subbing that in, putting in the 85 degrees as the angle of c, and then solving through for the length being 19.15 centimeters, which seems to be what the majority of you guys got, which is awesome. So the next bit is to actually find the angle PRQ. So that's this angle here. So that's when we actually go back to using the sine rule. So we have this length and this angle. And we have this length, which means we can therefore use the sine rule to solve for that angle here. So sine of PRQ is opposite of 12, and then sine 85 is opposite 19.15. So the answer from before. So good thing you guys all got part A correct. From what I saw last time as well. So then hopefully you had the right value to sub into here. Then we just rearrange for sine PRQ. So then go sine 85 over 19.15 and multiply it by the 12. Go through, take the inverse sine to get PRQ on its own, and that angle ends up being 38.64 degrees. Hopefully you guys are all good with that. And the last bit is to find the length PS. So now we have that length PR, and we have this angle here, got the length there, and then what we actually have to do, so we can use our sine rule, so sine SPR, so this one here, we can find that angle, because we have our 18 centimeters across from there, and then again we had that 102 and the 19.15. So we solve through and we get the angle of SPR is 66.8396. So then angle PRS is going to be 11.2. If we treat that as a triangle and go 180 minus 66.8 minus 102, we get 11.2. So then to find PS, which is opposite that angle there, what we can do is again use our sine rule, substitute in our values, and we end up with 3.8 centimeters, which again seems like the majority of you guys got. Cool, for the most part it seems like everyone was on the right track. So if there was any issue with any of those questions and you want me to explain a specific part, feel free to let me know and we can go back over that. But our solutions are all in the slides as well. Alright, next bit with trig, so we have our area of a triangle, so we know that area can be given like so. And using trig rules, we can obtain another rule for the area of a triangle where we have area equals half BC times sine A. So we need two sides and the included angle So if we have this side, and this angle, we can figure out the area of the triangle. So here's a question for you guys to find the area of ABC. I'll leave that up for you guys to have another go. It's about 10:29 now. So yeah, I'll give you guys about 5 minutes to have a go. How would you find the area of this triangle here? What was I going to say as well? Yeah, I'll leave that there. Have a think about all the trig we've used so far, and I'll open up a new poll as well. So hopefully this is some good retrieval practice for you guys. Area of the triangle. Alright, I'll leave that up for a few minutes. We might cut this one down to maybe 3 or 4 minutes, just so we can stay on time with our lecture as well. Alright, time is 10:34, so checking in with our Slido. Nice, so we see quite a few people have said about 39-40 centimeters. So let's have a look at that. So what would we probably do first? So the first thing is that to use our area formula from before, we want to figure out what is the... So remember how we said we want two sides and then the included angle? So what we can do is basically find any included angle and then go from there. So first thing is that the one we've picked here is that we want to find A. So we're using the cosine rule where cos A is our unknown. Then we chuck in 8, 10, and 12 into their respective spots, rearrange, and hopefully get 41.41 if you did that angle. And then what you can go from there is then substitute it into the formula for area, where we have BC sine A, and that's so we have our 10, our 12, and then the included angle, which we just calculated, was 41.41. So we get an area of roughly 39.69 centimeters squared, which seems to be what the majority of you guys got. So if you had any issues with the answer, just double check what your included angle was, just making sure that you got the included angle and that you did the calculations there all good with the cosine rule. Alrighty, otherwise that is our little bit for trig. So a couple more things. Extensions and applications of these principles include using bearings, angles of elevation and depression, problems in 3 dimensions, and angles between planes. So those base rules we looked at are fundamental for all of the applications. So again, methods is really about having the simple things really well practiced and well rehearsed so that you can apply them into different problems. And if you're getting to the point on your methods prep where you feel like you've got a pretty good understanding of all the basics, start then trying questions from all different sources. I'll speak about that a little bit more as well with Edit Limited and what we can do with that. So what I'm going to leave you guys with for the break, if anyone is interested, is this challenge question. So I'll leave that up for over the break, but before we get into that, I'm going to deactivate that poll. Thanks guys again for your responses, and if I don't have any questions, but again, I'll log into Slido and just double check that is the case. Just check we don't have any questions waiting to be approved that I've missed. No, it looks like we're all good. Alright. So, the other thing I was mentioning before was that we have TuteSmart. So if any of you guys are looking at doing like a one-on-one session, it's not too late to get some tutoring in preparation for your externals, especially if you just want to sit down maybe for a session or two and just go over some topics that you feel like you're struggling with. We have a lot of really great methods tutors here at TuteSmart. So we have our one-on-one private tutoring as an option for you guys. If you head down here to this website, you can book an info call with David and essentially be able to arrange a session between you and a tutor. So if you'd like to work with me in particular, you can mention that as well specifically, and then we can figure out a time that works between us two, as well as with Michael, our other methods tutor. And we have actually quite a few tutors who are able to take methods, but also obviously all of your other high school subjects. So definitely check out TuteSmart and consider doing a session with one of us, and we can really help go through what you need to work on and prepare you for your test. So now we're going to have our break. It's 10:38, and I think we'll make it a nice round. I was thinking roughly 15 minutes, so we'll come back 10:55, and like I said, we have this challenge question you guys can work on over the break. So what I'm going to do is if you guys want, you can download the slides and have a look at the challenge question there. Otherwise, I'm just going to leave it up on the screen as well. So this is one of those more like applying it into the 3D situation type scenario questions. So if you want to have a go at that over the next 15 minutes, I definitely encourage you to. If you feel like you want to extend yourself a little bit, have a go at some more math. So I'll leave that up there. And please submit Slido questions over the break, and then at 10:55 we'll pick up again and continue on, and especially start looking at statistics. So go get some morning tea. I'm gonna go and get some more actual tea, to help my poor throat. I've got a bit of a cold, but yeah, we should be good. So I'll see you guys at about 10:55. Those notifications, goodness me. Go away. Okay. Sorry guys. It's about 10:55, so I think we'll get back into it. Hopefully you guys did alright with the challenge question. Before we get back into that though, I'll tell you guys about Ed Unlimited. So like I was saying at the start, we have this thing called Ed Unlimited, and it's essentially one place where you can access all of our study guides, practice questions, we've got trial exams, and also text guides for all of your English and literature novels and plays and everything. So a really great place because you especially have the math methods topic tests as in there, as well as just like your usual course notes, and we also have a practice exam in there. So again, methods, the best way to practice is by doing questions, so 100% recommend you guys check it out. And if you get my code Boyana QCE, which I really recommend you do, you can use it completely free for 21 days with no lock-in, nothing. So you can really just go in and check it out for 3 weeks, basically, which ties in quite nicely with your exam revision. So if you go Boyana QCE, if you use that code when you sign up, you'll get it free for 3 weeks. So I definitely recommend checking that out. But also, if you want to get one of your classic books, you might have seen these around. I don't know if you went to the TS Expo in Brisbane, or you might have these already yourself. But we have a offer at the moment. If you use the code 15SEP on checkout, you'll be able to get 15% off your order. So definitely worth checking out if you do want to get that hard copy. And again, math methods topic test is 100% what I really recommend. So definitely check that out. But I'm gonna check in with Slider before we get in. So we got a couple questions. So my connection just dropped out. It isn't allowing me to re-enter as it is asking for password. Kindly allow me to re-enter, please. Oh, that is hopefully our admin team will be able to sort that out. I'm not sure why it won't be letting you back in. Just want to check. Yeah, our stream's still all good. But hopefully you'll be back onto the stream soon. Also, I really hope it wasn't the password thing that was showing up on mine. So we just got a question as well. So where do you put the code on Ed Unlimited Online? Sorry, so I believe when you sign up, there'll be an option somewhere for you to put in like a promo code. If you put in Boyana QCE, it will be free for 3 weeks. If you have any more issues, like if you want to check out the Ed Unlimited website right now, and then if you can't find where, at the end of the lecture, just let me know and I'll be able to take you through it like on the screen. We can do that together at the same time. So definitely write down that code, guys. It was Boyana QCE. My name is spelled Bojana, and then QCE is QCE. So it will be somewhere when you go in to sign up for Ed Unlimited. If you put the code in, it will switch onto the deal. Cool, and then we have the challenge question answer. Ooh, very nice. We got someone who actually popped in an answer. So I'm gonna keep that. I'm not gonna resolve that. I'm gonna keep that up there, but I'll put the solutions up here. So for part A, and I don't think just because we only have about an hour left, I've got the solutions here. So about how you can kind of find the answers. And if we have some time at the end, we'll go through it. But thank you to whoever did the challenge question. Really good practice. So all the solutions are in the slideshow. And if you are still stuck on that, we can go through it together later. But thank you again for having a go at that. Alrighty, so I think, yeah, so if you want to check out the solutions to the challenge question, it's in the slideshow, everything, all the working out is in there. And now for block 2, what we're going to be doing is having a look at probability. So particularly checking out the binomial distribution and continuous random variables. So actually, I'm just going to go real quick and just show you guys something, if I make that really big. So this is what I kind of, this is an example of like a summary sheet that I made up in year 12 to kind of go through statistics, because something I really struggled with was actually figuring out what statistics am I using when I'm doing a certain question. So like I'd get to a question and I wouldn't really know what was I even looking at. So hopefully we'll be able to get a little bit of a kind of broad idea of the different types of distributions, different types of stat that we'll be using in Unit 4. And this will be some good revision for you guys as well. So first thing is the difference with a Bernoulli and a binomial distribution, if you will. So I'm actually going to open up a poll for you guys to differentiate? If anyone has got the answer, it'd be good to hear from you guys. I'll just do an open text again. So tell me what's the difference with a Bernoulli or a binomial? Or if you don't really know what the answer is exactly, even just have a go at telling me what is a Bernoulli trial, what's a binomial distribution, anything you remember. So use this as an opportunity for some recall as well. So feel free to just go ham, write down anything you guys remember about either one of those things. So I'll leave it up for a few minutes so you guys can have a go. But again, yeah, thank you very much for the challenge question answer. I will keep that there now. So again, something that you might find useful with statistics is actually to just have a go at, all right, so continuous random variables, for example. What do I know about it? And just have a go at recalling everything and see if you can kind of have a really good understanding of the content itself, associated formulas, the different kind of characteristics of each one. Because what I recommend if you're struggling with something like this is to make a big summary, essentially, of your different types. Kind of like that messy map that I made back in year 12. Nice, seems like everyone's actually got the right idea. So Bernoulli has only one trial, while a binomial could have more than one trial. And Bernoulli has a single trial, whereas binomial has multiple. Bernoulli n equals 1, so there's only one trial, so then your expected value is just the probability. Awesome. Bernoulli is a single binomial trial, and then Bernoulli is one trial and two possible outcomes. Binomial, fixed number of trials, again, two possible outcomes. Awesome. This is really great, guys. So anyone who's a bit stuck on Bernoulli or binomial, anything that your peers have chucked up on the screen here works really, really well. Yeah, that's really great. So yeah, the biggest thing, Bernoulli versus binomial, is that Bernoulli is just a single trial. So it's like if you flip a coin once. I really like actually this explanation here that you have only one trial, so then your expected value is just the probability of the event itself. Both involve discrete variables and two outcomes, failure or success. Awesome, you guys crushed that, honestly. So if anyone wants some notes on Bernoulli or binomial, honestly, it is all up there. So definitely check out that poll. Yeah, so Bernoulli sequence, couple things there. You guys already talked about most of it. So you either have success or failure. Probability of success for each trial is constant, and trials are independent events. The number of successes in Bernoulli sequence of n trials is called a binomial random variable. So as soon as you have more than one trial, it becomes binomial essentially, and you have the binomial probability distribution. So that's how we have our formula here for finding, with our binomial distributions, the probability of a certain number of successes. So we have an example question here, which I think I'll leave up for a bit. Just trying to think about if it's worth more going through the content and then coming back to questions, because you guys can access all these questions in the slideshow and then go through the solutions as well in your own time. But what I will point out for you guys quickly is in the formula book, again, something really useful is to actually break down this page of the formula book, go through, and this can be a random revision activity. It's a bit of a strange one, but hear me out, it actually does work. So you go through and you kind of annotate this whole thing, especially when you get down here. You have a lot of like there's a lowercase p just everywhere. You have n, where you can actually go through and define what all of these are. So I recommend even just like getting a copy of this page and then splitting it up into the different topics. So there's pretty much 5 or 6 main types of statistics you guys should be familiar with, and I'll type up a little summary for you guys. Just open up a new page. If it will open for me, new document. Okay. So kind of the summary of the 5 statistics topics you guys should be really confident with and be able to differentiate between is we have Bernoulli, we have binomial, discrete random, continuous random, the normal distribution, and then sample proportions. And a lot of these kind of like interweave a bit, but if you can kind of go through all of these, explain what they are, the associated formulas, how to use them on your calculator, kind of keep that as your backboard for a lot of that section of Unit 4. Alrighty, but heading back to our slideshow, I'll end that poll there. Thanks guys a lot. So find the probability that when a fair six-sided die is rolled 6 times, there is 1 3, 2 3s, 5 3s. Hopefully you guys feel alright with substituting that into the formula and also being able to use it on your calculator. So I will skip over that tentatively, but again, most graphics calculators should be able to do this for you. Unfortunately, everyone probably has a very different calculator. The one I've got is the Casio graphics calculator, but different schools use different ones. So depending on which one you have, for example, this is the one that Michael would have used, the original lecturer for this session. So usually textbooks or even online, you should find explanations for how to use the graphics calculators for different settings. But again, another thing I really recommend you get very confident in before your external exam is sitting down with a calculator, knowing what each different function means and how to use them for your tech active questions. Because it'd be really annoying to get to a tech active question. You know it's super simple to be able to just chuck it into your calculator, but you don't know how to do that. So this is an example, the Casio, if you use the Casio, if you use the TI Inspire, this is how you would be able to go through that. So definitely, if you use either of those calculators, just go over again how to use the binomial distribution in there. Alrighty, so another thing with binomial distribution is we may also be interested in the probability that the number of outcomes will be in a certain range. So you can do this by hand by just adding the probability of all the outcomes that fall in that range. So if it's out of 10 and you're doing greater than 4, you can add up 5, 6, 7, 8, 9, 10. Less than 8, you do everything up until 7. So 0, 1, 2, 3, 4, 5, 6, 7. And then, for example, this one, actually, I'm going to ask you guys, what numbers would you add up if it was greater than or equal to 2 and then less than 6? This is something that surprisingly can get quite tricky. What would you add up? Oh, sorry, what numbers, if that makes sense, what numbers would you add up for the question circle? So literally just list what probabilities would you add up. Open text, launch that for us. Alrighty, also someone asks, do we need to know arithmetic sequences? It was on my mock exam, but never learned it in class. So it's a bit of a tricky one because technically, no, you shouldn't have to be, you wouldn't be directly assessed on arithmetic sequences because it isn't a syllabus dot point for Unit 3 or Unit 4, even though they do say it's assumed knowledge. So if they do find some way of using an arithmetic sequence super obscurely, in the external exam, it's extremely unlikely is what I would say. It's not directly accessible. They can't just make a question purely on arithmetic sequences, but I don't think I think because they assume that Unit 1 and 2 is something that you already know when you do Unit 3 and Unit 4, that they might, I don't think it's directly impossible, but I don't think I would worry too much about it, because it might be as well that your school just created a mock that did use arithmetic sequences when it maybe shouldn't have. So probably like what I'd say is like my safe answer is it's extremely unlikely that you would be asked on it. There are a lot more other things in Unit 3, Unit 4 that QCEE will be interested in assessing you on. Arithmetic sequences probably wouldn't be one of them. So again, for this one here, what probabilities would you add up if it was greater than or equal to 2 or less than 6? Hopefully we've got a couple answers. Nice. Okay, perfect. Everyone's got that down pat. Good. So you would include 2, 3, 4, 5, and then you would not include 6. Really good. Okay. You guys are actually killing it today. I will deactivate that poll there. And then again, you can also use your calculator setting. Those are in the slideshow there. And if stuck, probably ask your classmates to have the same calculator, ask your teacher. Just really make sure that you understand how to use those functions. So again, binomial distribution may be used in problems involving conditional probability. So if you remember this formula for conditional probability, where this indicates an intersection here, probability of A and also B occurring. So here's an example question. So there's a 90% probability that any given person is right-handed. In a classroom of 26, find the probability that there are 20 right-handed students, given there are at least 12. Okay. So we're basically using the information that we want to find the probability of there being 20 right-hand students, and we know that there are at least 12. So how do we actually go about that? So first of all, and this is what I recommend for all statistics questions, first of all, identify the type of statistics you're dealing with. So here you'd be like, okay, I'm dealing with a type of binomial distribution because we have a success or a failure, so being right-handed or not being right-handed. Binomial. Also, that's so messy. So I'd literally do this on my exam. So another tip for kind of being able to figure out, all right, what content do I need to bring out here, is that I would sit down. So like if I was going through my paper and got up to a question and I'm like, okay, it's a statistics question. What topic of statistics are they actually assessing? I'd literally write it down. So of those 5 that we had written down, I would straight up write that word, whichever one it was, at the top of the question, just so I could kind of keep track of and kind of get in the right mindset of that type of statistics. So I'd write binomial distribution. Okay, I can use those things. So we define the probability of success. So probability of being right-handed is 0.9, and we have a classroom of 26. So to find the probability that we have 20 right-handed students, given that there are at least 12, that's how we would set that up here. And then we just substitute in the rest of the formula like that. So using our calculator, we'd be able to quite easily find x equals 20 and x is greater than or equal to 12. And then we substitute those values in and we get 28% in the end. So that's just an example just to demonstrate how we can have conditional probability tied in with the binomial distribution. Alrighty, so to make predictions about a binomial distribution, we may wish to determine the expected value and variance for a given number of trials with probability of success p. So you have your expected number or expected value there, and then the variance can be given there. And then your standard deviation is going to be the square root of your variance. Alright, so very quick example, and I'll get you guys to have a go at this without putting the formulas up for you guys. So hopefully you can identify them in the formula book. This shouldn't be too tricky, but find the mean and variance of the binomial random variables. We will do, let's just do all 3. We'll do all 3. Actually, no, I changed my mind. Sorry, guys. We'll do the first 2. So A and B, open up a poll. So hopefully this is just some quick revision. Answers for A. Check that up for you. And that's A and B there. So I'll give you guys a minute or 2. I'll probably give it maybe another minute, and then we'll have a look at the answer together. Okay. Hopefully got some slider answers. Very nice. So I'll give you guys another bit. Alright, so we've got a few more people chucking in their answers. Looks like again, most people have got the same ones. Alright, what I'm going to go through is first one. So we substitute into the expected value will be n times p, so that should be 13.2. And then our variance is n times, if we go back, n times p times 1 minus p. So that should be 22 times 0.6 times 0.4. That will give us 5.28. And I think everyone got that. Awesome. That's really good. And then for B, again, substitute in using the exact same process, we should get 129 and 90.3. Which again, I think just about everyone got. Great. Awesome. Thanks, guys. Cool. So that is a little bit just revising binomial distribution in terms of calculating expected value and the variance. Sorry, my brain is starting to fall apart with all the different words. But often you may wish to know how many trials you need to conduct to be reasonably sure you'll get a certain number or range of desirable outcomes. So you might have a binomial distribution with a probability of 0.35, and we want to know how many trials are needed to make the probability of having at least one success greater than 95%. So this is where we're starting to kind of take the binomial distribution and start to put it in context a bit outside of just the straight up calculations. So what we want to find out is the probability of x being greater than or equal to 1 is going to be greater than or equal to 0.95. And then we can kind of rewrite that as 1 minus... So this is actually something to look out for as well. The opportunity to rewrite So for example, if it being greater than or equal to 1, that could be any number of things. So what we want to do is instead go, all right, we'll go 1 minus the probability of it being 0, and that will give us the probability of it being 1 or anything greater than. We want that to be, and then if we rewrite that, rearrange, probability of x being equal to 0 should be less than 0.05. We substitute in that formula from before, the binomial distribution formula where x is 0. We should end up with 0.65 to the power of n is less than 0.05. We take the log of both sides, then end up rearranging for n. So feel free to come back and check out this slide as an example of how you can apply the binomial distribution into a bit of a different context. So again, suppose we have the same situation and we want the probability to be greater than 95%, but we want at least 2 successes. So now we kind of do the same thing, but now instead of having it equal 0, it will be the probability less than 2 is equal to is less than 0.05. So that's just an example of another kind of setup where instead of just having 0.65 n is less than 0.05, we have 0.65 n and everything else from that formula, because now we don't have 0, we have 2. So what can we actually do with that? How do we solve that? Because that looks hectic, doesn't it? That looks absolutely hectic. So we can't solve it algebraically, so we need to use our graphics calculator. So usually you'd probably use your solver function. Hopefully that's one that you'll have built into your calculator. This is an example again of how to use it in the Casio scenario, how to use it in the TIN Spire scenario, depending on which calculator you have. So again, that is also in the slides. Just going to check in with our questions. Don't think we have any more waiting in there. I'm going to deactivate that poll. Thanks again, guys. And we're going to start looking at our continuous random variables. And we have about 40 minutes, which is good. So we've had a look at some discrete random variables, and we're going to hopefully now have a look at some continuous random variables. So the difference between discrete and continuous, so discrete means you have a very certain number, as the word discrete suggests, whereas continuous random variables are numbers which can have any value within a certain interval in a set of real numbers. So classic example is, height, time taken, distance traveled, and things that we measure are typically continuous if you ever do get confused on that. So the next thing is that data can be used to approximate a continuous random variable. So one example is that we can use class intervals to create bands of data so that it can be modeled as a histogram. And as the sample size increases and the class interval gets narrower, the histogram approaches a smooth curve. And we can call this our probability density function. So the probability of being, for example, from this value to this value is going to be that area in there. So you can see how now we're going to start to bring in the idea of integrating, just like that. So probability density functions have two main properties. First one is that your y value is greater than or equal to 0 within the entire interval. You never have a negative y value, it never goes below the curve. As you can see here, it's always above. And then if you integrate across a certain interval, that should, so basically if you go from the minimum and maximum bound, so if you integrate the entire graph, the area will be equal to 1, which makes sense because all of your probabilities should add up to 1. And that's how you represent it in the graph form. So a definite integral of a PDF between two bounds gives the probability of acquiring values within that range. So if you want to find the probability of being between like 160 or 170 centimeters tall from a certain probability density function, you would integrate between those two values. And that area gives you the probability. All right, so we have an example here. So actually, I'll leave that question up for you guys to have a go at, just like fresh probability density functions. Using the information before, prove that this function is a probability density function, and then also find the probability where x is less than 1, where x is given by the function itself. But I just want you guys to focus on part A. I'm just going to ask you guys actually, how would you go about doing that? How to prove it is a... So this is actually a classic exam question. I remember doing this at some point in my externals, or was it one of my maths exams in year 12? We definitely did this. So how would you actually prove it's a probability density function? So this could be like an example of a 1-mark question or a 2-mark question, kind of chucked into a bigger question with a lot of different parts. So what would you do to prove it's a probability density function? What kind of working out would you show? You don't have to type out the working out, maybe just explain the process, have a go at explaining that. So again, that's just what the question looks like there. Cool, got some answers coming in. I'll give you guys a bit more just to get everyone else's thoughts and opinions. And this is actually a good question to kind of demonstrate and work on how you communicate your knowledge to a marker. So something else to think about with your exam approach obviously is to think about, okay, am I writing out my answer in a way that makes sense to someone else reading it? Is it really clear? Am I making sure I'm definitely going to get the marks from the mark having looked at it? Are they going to be able to pick out all the marks from the way I've presented the information? So especially questions where you have to like evaluate reasonableness or demonstrate, like prove something. There's not a lot of it in methods, but the amount that we do, it is important to ever communicate clearly. So this is a type of question where you have to make sure that you are communicating why the working out you're doing is proving that it's a probability density function. And yeah, it looks like everyone has got it. Yeah, so you would integrate between the bounds, the lower and upper bounds of the function they've given, and if it equals 1, you got a PDF. If you don't have 1, then it's not a probability density function. So A+ answer for everyone there. So an example of how I'd probably set this out in an exam is I'd think about, okay, so I would go, what do we have? The first thing I'd say, probability, I would state the kind of like the condition that PDF integrated from upper to lower bound will equal 1. And then you can do the little therefore symbol with the 3 dots. I love using that thing. So therefore, integrating f of x from whatever the bounds were should indicate if it is a. That's like an example of like being super like kind of extra with the explanation. Then you'd actually just do the working out and then be like, therefore, or then you go, you know, the integral is equal to 1, and then you kind of have your concluding statement. Nothing crazy, you don't want to start writing an English essay, but just saying, therefore, you know, it's PDF because the integral is equal to 1. So that's just kind of like an idea of how you want to just keep the information clear, flowing, make sure that everything is there. Alright, thanks again guys for your responses. Alright, again, so you'd test this. Yes, it is a probability density function. Alright, and again, you can use a graphics calculator to do integration. So some examples of how you would use that on your respective calculators. So like with discrete random variables, we may wish to find the mean or expected value and also the variance. So the expected value is given by the following formula, where you take the function, you multiply it by x, then you integrate from the lower to upper bounds, like so. Here's an example. So find the mean of a continuous random variable with its PDF given by the following. So I'll just show you guys the working out there. So you'd substitute in your upper and lower bound. You'd multiply the function by x, so it becomes 0.5x squared. Then you do your usual integration from there for a definite integral. And the working out is listed there. If you want to check it out more in a bit more depth, it's in the slideshow. And again, graphics calculator can do the following, where in this calculator you would just define the function and then chuck it into a formula, or you can also just, you know, have a go at it yourself by actually putting in the 0.5x squared rather than defining the function first. I have no idea why that animation is there, but it's kind of fun. Completely forgot you could do that with PowerPoint. Alright, so then we have the idea of percentiles. So the equation below can be solved to give the qth, like the letter Q percentile of a distribution. So if we want the 75th percentile, we will set Q to equal 0.75 and then solve for P. So going from the lower bound, we're going to solve for what is the upper bound that will give you the first 75%. So that's an example there. So here's an example of that in action. So given the probability density function, the following, find the value of x for which 90% of values fall below it. So what we would do is we're trying to find p here, and we set it to 0.9. So we integrate and we keep p as a variable. We keep going through keeping p as the variable. We're going to have to use some logs to be able to rearrange and get p on its own. But that's essentially the main thing there, is that you substitute in p is what we want to find out, and you keep going with the integral. It might look a bit scary because you have like minus p over 3 as a power, but if you just take it easy step by step with your rearranging, you should end up with p equals 6.9. And then we have the idea of the median. So the median is when you set it, you try to find what's the upper bound when you have 0.5 as your area. So median is just like any other percentile, but you set the probability to 0.5. And then we have our variance. So this is our variance formula, hopefully familiar with and you would have seen before for your continuous random variable. It is in your formula book. And since variance looks at the average of the square of the difference between your expected value and the mean, it is not in the same units as your as your x variable, not your mean. So to get an understanding of the spread in the same units, we will use the standard deviation, where we just take the square root of the variance. This is kind of a bit more context. Don't concern yourself too much, I guess, with the thinking behind why we have variance and standard deviation. Just be familiar with how to calculate each one. Alright, so another example question, the amount of time customers need to wait in line at a cinema is given by the following function. So what it's asking now is to find the value of k. Also find the mean of the distribution and find the standard deviation. So it seems like you guys have a pretty good fundamental understanding, and hopefully this is some revision for you guys. But I will give you guys a chance to have a go at this question. I'll give you guys about five or so minutes to have a go, at least at part A. If you get to part B and C, that's awesome, but definitely at least have a go at part A. So finding the value of K, and if you have extra time up your sleeve, then definitely have a go at B and C as well. So answers to A and B, C if you get them. So I'm going to launch that poll for you guys, some quick math, and then we can go from there. I'm also just going to go and grab a tissue while you guys have a go at that. Time is 11:32, so at about 11:36, 37, we'll start having a look at it. Alrighty, about time. Let's have a look at that answer there. So we've got k is 1 over 2,500. 16 over 3. Cool. So we've got 5 and 1/3 for the B value, and then C, we got a couple in there as well. So feel free to keep chucking in your answers if you're still going, and we'll go through the answer now together. So finding the value of k, what we would do is, again, so if we integrate from lower to upper bound, it should equal 1 if this is a probability density function. So we go through, and this is one way of working it out. We would take out the k first, figure out the rest of the right hand side, and essentially hopefully end up with what everyone seems to have gotten, which is 1 over 2,500, or 2,500, or you can write that as 0.0004. The next bit is to find the mean of the distribution. So we substitute it into our mean formula now that we know what k is. Chuck it into our calculator, or you can work it out by hand with help of a calculator, and then we should get 5.3 recurring. So that's 5 1/3 that everyone has gotten so far. And then for the standard deviation, again, we will substitute into our formula there, and hopefully we'd have to take the square root of the variance, and we get 2.21, which seems to be everyone's answers so far. Awesome. I'm going to end that poll there. Thank you, guys. And we've got a question in here, which I'll just answer now while we're at it. So I was just wondering, earlier you said about how today was when QTAC applications are due. If I submit my application, when will I potentially receive offers? So you can actually have a look online at the QTAC offer rounds. So the key dates there, they'll tell you, depends on what courses you've applied for. So most, I think the typical release date is early January. So you can see here, these are all of your different offer rounds. If you have an early offer round, offers released here, you can see. So yeah, Thursday 12th of January is like the typical uni offer release, but you can get uni offers any point here depending on when you've applied, what you've applied for. So it also depends on which university preferences you've put into your application, but typically I'd say the majority of degrees will be released probably in January after your ATARs are released as well. So your ATARs come out in December, about the 3rd week of December, and then QTAC offers usually come out in the January round, and then you have all your subsequent rounds after that as well. So this is a really good website link that kind of just tells you when you can expect offers, and you'd have to cross-check it with your the specific, the specific preferences that you've put in. Alrighty, and then we also have the idea of the cumulative distribution functions, but I'm going to kind of leave this slide just for the sake of time, because I do want to get through to the normal distribution and then wrap up with our study tips and open Q&A. So last little bit for today, and we don't have any more questions. So the normal distribution, here it is essentially. We have, this is our typical shape for the normal distribution. If we have the standard normal distribution, it's specifically when we have a mean of 0 and a standard deviation of 1. But then you can apply the normal distribution, that bell curve shape, to any kind of range of values that you want. You can have a different kind of a different function for that. So this is where we have the idea of the z value. So first thing is to be familiar with the idea that normally distributed data sets, we can say that within 1 standard deviation, we have 68% of values. Within 2 standard deviations, we have 95%. Within 3 standard deviations, we have 99.7%. So this can kind of help make quick statements about a given distribution. And then we have the idea of the z-score. So the z-score is how we can take, so if we go back here, take a general distribution and turn it into a standard distribution. So we can basically find out how many standard deviations is a value away from the mean. So that's how we can calculate our z-score. So if we take that x value, whatever the value is, subtract the mean from it, and we divide it by the standard deviation, that gives us our z value. So if it's a positive value, it'll be above the mean. If it's a negative value, it's below the mean. That's some more information there. And again, some calculator explanations there. If those are your calculators, check it out in the slideshow. Alrighty, so in a Year 12 maths class, here's an example question. The percentage score of students in an exam is normally distributed with a mean of 73 and a standard deviation of 6. So find the probability that a student picked at random received less than 68% on the exam. Find the probability that a student picked at random scored less than 70, given it is known they scored less than 80%. So again, we have this idea of conditional probability showing up in this question. But also, so again, how would I probably go about doing this in an exam? So I'd be looking at it, I'd be like, all right, normally distributed. So that means that we're probably going to be looking at the normal distribution topic there. So we've got normally distributed. That's the first thing I'd write down. We're looking at the normal distribution, and then I'd start thinking about what can we use here. So we have the idea of z-scores, we have the idea of a mean, a standard deviation, all those values are given there. So another thing with your external is have a think about, breaking down the question, being able to identify the information that you do have, as well as the information that you don't have. So for finding the probability that a student picked at random received less than 68%, so again, we can use our graphics calculator. This is the example for the TI-84 Plus, where you can just chuck in your lower and upper bounds. So your lower bound would be, negative infinity. Your upper bound is 68. Your mean is 73, and your standard deviation is 6. So usually you'll have like a normal distribution kind of function on your calculator where you'll be able to substitute in those values. And then the answer is that you'll have a 20.23% chance that someone picked at random scored less than 68%. Then we have the idea, again, with the conditional probability question. Things to look out for is to be able to translate the probabilities incorrectly. Again, you'll just use your calculator to find those individual values, and then substitute in and solve from there. So then what we get is the value of 35%. All right, so we have a question that says 10 minutes, and in terms of the final kind of content, just want to take you guys through. I think what I'll do is just pop up a question and then go back onto, I'll pop that question up, this one here. Feel free to have a go at this, and of course the other questions that we didn't quite get enough time to today. All the explanations and the solutions and answers are in the slideshow, so use that as a revision tool. Definitely download that. But because we have 15 minutes, here we go, got some questions just going to answer. My slider will load. What we'll do for now, for the last bit, I'll go onto that poll, see if there's any last topics I can kind of go through with you guys in 15 minutes. If there's something you want to go through, just chuck it in the Q&A. But we have a few questions in here I'll address. Just let this load, and also I'm going to open up the last poll. All right, here. So we have someone saying, wait, QTAC doesn't close in December. Is it actually today? Very scared right now. So you have to actually just lodge your application. So create the application, but you can change your preferences way later. So today, just make sure you have a QTAC application. So you can see the key dates again here. Where is our applications? Ah, that's not the one. Application dates. I'm trying to find for the exact one. Yeah, so you're able to actually, as long as you lodge your QTAC application by today, that is the main thing. But you can change your preferences all the way up until December. So do not freak out. I apologize if I made you freak out a little bit, but yeah, you don't have to worry about the preferences. You can change those well leading up until December. So apologies for the confusion there. So when you're using test scores, why is the lower bound negative infinity and not 0, seeing as you can't score less than 0? So for the test scores, I'm guessing you mean test scores. Sorry, I apologize if I don't actually know exactly which part you're speaking about. Was it when I said negative infinity with substituting it into here? Where is it? Because I think possibly for like the lower bound here, the reason we just have negative infinity is just to account for the fact that this, in terms of the actual distribution itself rather than the test score itself, so looking at the distribution of the values. I'm sorry, I'm probably butchering the answer to this question, but feel free to chuck in like another question just clarifying. So when you're using test scores, lower bound to negative infinity and not zero, seeing as you can't score less than zero. I think it's that one that I'm mentioning at the moment. So it's just kind of ensuring that you get, because you know the way that this curve tapers out, you can, I guess you can just put zero, but I think the way that the curve tapers out, it's just, I guess, common practice. I guess it's an approach to put in lower infinity. I don't think it makes directly a difference. Even though you're right, though, I can see what you're saying. You can't score less than zero, so then that it isn't a necessary thing to put in negative infinity. So I think I'll say that. I guess you would be correct that you can kind of put either one. It wouldn't make too much of a difference. On the lower bound there into negative infinity. Yeah, okay, cool. So I'd probably say, yeah, because it is a test score, you're right, actually. You can probably just put zero. But you can also put negative infinity just as a general thing, because with the, I'm trying to explain, like with the distribution. So if you're looking at it in terms of like, sorry, the word's completely blanking, but if you can kind of understand that you can have the score from like 0 to 100, but if you can also look at the percentage of people that scored like certain grades, if that makes sense. So it kind of depends on what the graph is, but just for simplicity's sake, I'm going to say the lower bound can be 0 as well as negative infinity, and it wouldn't change the answer to that question. So realistically, that graph would end at 0 directly. There wouldn't be anything lower than that, but there might be some scenarios where the graph will just curve beyond into negative values depending on the scenario of the question. But yeah, last poll for today, for our last 10 minutes is, it's always nice to hear as well, one thing you guys will take away from today's lecture. So, you know, whether it's like a different thing you'll try to approach in methods, a bit of content. I'm just going to clarify also that question. So, okay, thank you. Like, you mean theoretically it can be lower than that? Yes, that's essentially it. So, kind of theoretically it could be lower depending on the scenario, but you're right for that one. Because you can't score lower than 0, you can put the lower bound absolutely at 0. Hopefully that clarifies that. Yeah, so the last poll, just something out of today, like anything, any bit of real reflection with your methods. Last bit, I think I'll just talk about just for the last like few minutes is with your exam approach. 100% guys recommend thinking about how do you spend time in your exam. What's your approach going to be? So for me in year 12, sitting maths exams, what I would do is I'd go through and make, during the reading time, just make a mental note of all the questions that I knew I could do. And then as soon as the writing time started, I'd actually just start with a list. I'd write down the numbers of the questions I'd do, go through and get them all done and pick up all those marks. Even if there was a simple familiar I wasn't completely confident in, like I didn't look at it and know how to do it, I'd just leave it to go back to later. So going through, doing everything you know how to do, keep an eye on the time, making sure that you do allocate a good amount of time to the complex unfamiliar at the end. And then I'd go back through and work through the questions progressively, the ones that I wasn't so confident on. 100% think about leaving a good, 5 minutes at the end if you can to go through and check your questions. Again, you wouldn't want to lose marks on questions you knew how to do, but you just didn't check over compared to questions that you probably you don't know what the clean approach was. Think about how you communicate your mathematics throughout the exam. So like I was saying with that example on here, yeah, how are you actually going to show the marker you know what the concepts are, and you understand how to kind of break down a question, be like, this is information I know, this is the information you need to know that I know, and then you give your working and have a nice clean answer at the end. So that's something else as well. Obviously things like checking your units, making sure your calculator work is clean and efficient. If you have time at the end of your tech active, go through and rerun your calculations, but obviously most people, like it's not a typical thing to have enough time to do that. Bernoulli versus binomial, awesome, that's really good. That's a really good thing to take away from today. Yeah, and also just another reminder, guys, if you did want to sit down and go through something in depth, we can do a private tutoring session as well. And we have a few tutors who are also able to help out with that. So, yeah, I hope you guys, you know, all the best with your external prep, essentially. Good to see got some things taken out of there. I'm just going to check out. I think we covered probably a lot of the little different bits and pieces today. We did have quite a sweep over Unit 4 especially. So if there's anything else, any other last questions you guys have with anything, feel free to let me know. So we got a question here. Was just curious as to what you found the most effective study method technique for methods. I struggle to know how to study maths. So what I found the most useful for methods was to have two separate notebooks, one for the content and one for just working through questions. I'd go through all the textbook chapters I needed to do and made sure I got the main formulas out and the main pieces of understanding, because you got to have a good understanding of the content before you can go in and have a go at the questions. So once you have like a solid set of maybe notes or like a summary sheet or something with all the content, and if you struggle with understanding it from like reading the textbook, consider consulting like a friend, a tutor. Also watching YouTube videos is super useful, especially like methods topics are done all over the world. So there's a lot of resources online kind of explaining things. I'd recommend checking that out too. Once you got that solid basis of content, then going on and having a go at just starting with simple familiar questions. So like I said, with deriving, integrating, like some of the basic probability questions, making sure you've really got those foundations solid. So that I'd actually spend quite a bit of time making sure I got all the simple familiar, and then after that, progressing forward. So like I did some content, I'd do a few questions, maybe leave it for the afternoon, and then the day after, go back in and complete some harder questions, making sure I still had those kind of simple skills down pat, but then now try and apply the knowledge into some more harder questions. So definitely a pattern of like content and then just questions and lots of practice. So with maths, it's absolutely making sure you got that solid base and then consistently studying methods throughout, probably up until your exam essentially. So that's what I found the most useful, was just to have consistent small amounts of method study, doing a few questions every day, and then obviously those bigger study sessions every now and again. And again, probably my biggest tip preparing for the external is to do as many practice exams as you can, doing questions under timed conditions, and getting used to that kind of time pressure as well. So even if it means making up your own test by saying, oh yeah, I'm going to do this set of questions from my textbook within, like I'm going to put a 20-minute timer, that kind of thing can be really useful. And then we have another question, any suggestions on where to find practice exam papers? So like I said, if you use the Boyana QCE code and go onto Ed Unlimited, we have a full length, like a proper external length paper on there. And it looks like a practice exam paper as well, which is really cool. So I'll put that code back up in case anyone hasn't got it. But it is, if we go back all the way, it is, we will get there. Wait, I missed it. There we go. Boyana QCE. So we have papers, you can see it right there, and it has solutions and everything included. Also, you can go to the QCAA website. Hopefully, you've already checked that out with all the practice papers on there. A lot of textbooks release exam at the end of the textbook, so consult with your teacher if they have any, if your school has access to some more textbooks. Be proactive, go seek out if they have any more resources kind of like hiding away. And then another place is actually the HSC and VCE papers. So New South Wales and Victoria have obviously a subject equivalent to math methods. While there will be some small differences, there are a lot of really useful questions in those practice papers as well, and they have heaps online because they've been doing ATAR for a long time. So that's another great place to look. You can go through and just have a go at some questions, especially if you're looking at kind of extending your methods prep. Looking at questions that are a bit different to the ones that maybe you're used to seeing is a good way of really extending yourself. Alrighty, but if we don't have any other questions, Someone's asked, can you quickly explain integration by parts, please? So I'm pretty sure by integration by parts you mean like integrating different parts of a function. So kind of the same with derivatives where you'll derive each step as you just go across. So you can integrate, so you have like a one big function, and if you split it up into little functions, if you integrate each part individually, then add it up at the end, it should result in the same answer. Apologies, I don't have enough time to kind of delve into the topic and just check actually we've got the same topic. But yeah, that's essentially our lecture wrapped up. And if you'd like a follow-up as well, definitely consider doing a session with one of us and we can go through it thoroughly. But thank you guys again for the time you've taken to come and check out the lecture. If any of you guys are doing general English, we have the English revision lecture tonight at this afternoon at 4 o'clock with Maddie. So definitely, just go back. Just go like that. All right. So yeah, check out the English lecture tonight. That's our last one for the Year 12 lectures of this week. Otherwise, all the best, guys, with your externals. Thanks for coming along again, and hopefully we'll get to meet you guys at some point. Otherwise, yeah, all the best for the rest of Year 12.